Alright, so you have watched the video where it gives an overview of models. Right now, this video is to give you an example. So models are used to explain phenomena. And in our case, we're going to be looking at putting diagrams and a small amount of text to try to explain a phenomenon. How do we start doing this? Well, you should always begin by trying to make observations. And that you can think of that as the information on your data. Then come up with possible explanations. So in the beginning of units, usually those possible explanations involves background information, right, that you have from previous classes as well as your intuition. For end of unit models, I'm looking for you to be able to incorporate topics covered in class with pre-existing knowledge. And then the third thing that you should think about before you begin a model is what is the phenomenon. Okay, so sometimes phenomena are very complex, and natural world is very complex. So you need to figure out what it is that you should focus on, because you don't want your model to be too busy or too complicated where people cannot relate to it. So let's begin by following this procedure. Okay, so I'm going to first begin by kind of just putting this together. This is some observations. Let me make this better. Observations, and then some possible explanations. Okay, some observations and possible explanations. So let's look at the phenomenon. Alright, so now you can make observations about a lot of things, so you need to try to focus on the topic at hand, which in our case is heat within the earth. Right, so few observations. The observations I notice here is that notice how the smoke is coming from the ground, but it's actually coming. I'll pause it here. It's coming from the crevices in the ground. So it's not coming from the dirt itself or the rocks itself. It's coming from crevices in those rocks. Okay. Also notice the title. You may or may not be able to see the title of the video is Mountain Lesson. I also take note of the color of the liquid, okay, and that's bubbling. Notice the color over here as well in the reservoir. Okay, and again I see that smoke coming up. I think that's enough. Alright, so some observations. So, smoke. Let me use a different one. This board is very small and the marker is very thick. Okay, some smoke. Okay, and it's coming from a crevices. Then the other observation is that it's Mountain Lesson. Okay. The color of the ground. Okay, it's kind of yellow, gray, right? And then there's some bubbling liquid. And then the color of the liquid is also gray. Okay? And obviously there's some vapor. I also noticed some vapor coming up. So a few observations I noticed. Okay, I think that's part of the smoke and the vapor is the same thing. Maybe I don't need to add this one because that's what the smoke is about. Alright, so this is few things I noticed. I mean, I could have noticed the trees. I could have put also the birds that were singing. I could have put the type of landscape, or time of the day, the weather. I could have made several observations. Okay, so I could have put up the observations. Your next step should be some possible explanations. And like I said before, it's a combination of your intuition with materials that you covered in class. If this is the beginning of the unit, that means that will be mostly your intuition, but towards the end of the unit, I'm really looking for you to touch on the topics that were covered in class. Okay, so that's the idea. So smoke and crevice, probably water vapor that's coming through the crevice, and I'll tell you why I think that's the case. Water vapor, okay. And the reason why I think it's water vapor is because Mount Lassen is a volcano. Okay. So the heat must be coming from underground. I also happen to know that Mount Lassen lays in a convergent boundary. I'll just put it here, boundary, BD for boundary. So I believe it is water vapor, and I think it's the smoke that's coming up is water vapor because not many liquids or not many gases have color. And I know the whitish color, and the fact that once it keeps moving up, it kind of disappears. It tells me that it's the water condensing. So it's just a condensation of the water, just based on what I saw. I know that the water is hot. That's what's creating the vapor because there's volcano activity on the ground. The color of the ground is yellow grayish. There's probably other gases and minerals present. That tells me that. And usually geothermal events have a lot of dissolved minerals in there. It's pretty common. And then the bubbling liquid is water under high pressure and temperature. High pressure and temperature. Okay, high pressure and temperature. The gray color, I didn't bring it up here, is probably from the stirring the sediment, right? So when something bubbles, it tends to stir things. It could be some minerals dissolved, again, like I said before. Oh, and I've been writing it, and I just realized that it's frozen. Sorry, guys. Let me try to shut this off. Close. And let me try to open again. Right, sorry. I've been writing it, and then I look at the screen, and it was frozen. So this is what I was saying, the smoke in the crevices, probably water vapor. Because the video is titled Mount Lassen, I know Mount Lassen is a volcano. There's a lot of heat on the ground. And I also know, and if you Google, you see that it is part of the Cascading Range, which is a convergent boundary area. The color of the ground is yellow and gray, probably due to other gases and minerals present dissolved in there. The bubbling liquid is probably water that's underground, the high pressure and temperature. Okay, and the gray color is probably stirring of the sediment. Okay, so that's my observation. Those are my observations. Those are my explanations. So in here, there's a lot going on. If I try to put all of this in the model, it would be a hot mess. Not pun intended. I need to focus on things that will help me explain the phenomena. The phenomena is this geothermal event where there is vapor coming from the ground. Right? That is the phenomenon. There's some vapor coming from the ground. And I try to make sure that you know what the phenomena is. So the phenomena is there's vapor coming from the ground. So I should focus on trying to model this. I should incorporate this because this is my explanation. Okay, this is where the explanation comes from. The color of the ground, not relevant unless the unit was about minerals. Okay, that would be relevant. The color of the water, not relevant unless I was trying to focus on that. The vapor itself, the way the vapor is set up when it goes up in the sky, again, not relevant unless I was looking for gases. I would focus on those two. I might incorporate a little bit of this. Okay. So I'll probably incorporate those three things in my model. Alright, so let's create this model. Alright. So let me put a title in here. Just to kind of ground me, I know it's heat. Again, this is way too big. Heat within the earth. And then every time I do my model, I keep going back to this. I need to make sure that I'm modeling heat within the earth. Alright, so then let's begin. I have my observations, right? I made possible explanation. I found the phenomena. So those are the three things. I made observations. I made some possible explanation, and I know the phenomena is heat within the earth. So the first thing that perhaps I should do is kind of model the earth. So you have here your core. And then you have several layers. You have several layers, and I'm going to put layers here. And then you have, because all the action is going on in the crust, I'm going to kind of zoom into on the crust. Okay, so I'm going to put this as the crust. And I'm emphasizing here that I zoomed in the crust, so it is not scaled correctly. So the earth layers are not scaled. It's not scaled correctly. And this is the sky. I can put this as the sky. Okay. So just put surface of the earth. Surface. Put here surface. Okay. So this is inside of the earth. Okay, inside of the earth, and this is just the surface. And maybe I'll even make the crust a little bit bigger. Okay, because again, this is where all the action is. Somewhere in my model, I would say that, and I'll actually in your video, I'll say it again, that you need to emphasize that this is not scaled correctly. It's just I want to show the phenomenon. Okay. So I have surface, not a lot of action going on. I have crust, and I have the core over here. Okay, and all the different layers of the earth in here. The reason why I wanted to start with the core is because that's the heat source, right? That's the heat source, and there's some conduction that's happening here, but it's primarily through the heat. Okay, the heat in here. Okay, it's primarily convecting. So that's the primary source. Okay. So next, So I would show that this is some convection happening, and I can actually write that down, or I can create a key. Let's see. I guess I can just write it down. Let's see. I'll use this as my key. There we go. I'll create this as my key. So I would do a key over here where I put this as convection. So again, trying to make things as clear as possible. Okay, so I'll have a key where I show that this is convection. So then we need to show a crevice. So pretend that this is a little crevice where the water is kind of boiling here. And then on the ground, I know that there's some water on the ground. Okay, don't try to show me every single crevice, okay, because it's going to get too busy. Okay, just you can point that this is a crevice, or it's one of those reservoirs, right? It doesn't matter. Okay, the phenomena is the same. It's just one is bigger, the other one is small. And I know this liquid's primarily water. Okay, so I'm just going to call this water. Again, don't try to put all the crevices, just one is plenty. Okay, here in this area besides water, there is a lot of magma and just really hot rocks. Okay, because what I know about this crust over here is that it is in a volcanic area. So I actually can write this down somewhere over here. This is important information. It is in a volcanic area. I'll just put a volcanic activity. Okay, so I know it's very hot in this area. So I would put that there is some very, very high temperature rocks in here. Okay. So how would I show the rocks? I guess I can show with dots like this. Okay. And in my key, again, if you try to represent something, you can represent however you like, as long as you have a key. I would put, and the only reason why I'm making the key in a separate piece of paper is because this board is very small, but ideally you would have everything in one place. So let me do that. I would put that this is rocks. Okay, so rocks, I'll put here volcanic activity, just to emphasize that those rocks are really hot because of the volcanoes. And then I would put a big arrow here indicating that the temperature is high. Okay, so fast moving particles or high temperature, it doesn't matter how you express that. And then let's look at our model. Okay, so we are explaining here that there's convection happening. Okay, and I'll talk about the convection in a moment. And then there's a gap here in terms of transfer. How is the convection affecting this? Okay. So I would emphasize that the convection is happening all the way up here. That's what's causing the heat transfer. So I think if you put the arrows a little bigger, you can definitely emphasize that. That's it. I think now the explanation that the heat is traveling through all the different layers and is actually getting to those rocks, and the convection keeps happening here. There's a small degree of conduction that's going to start to happen. The rocks are in contact with the water. I don't know. Oh, this is a great analogy. If you have a fire and you put water on that fire, you automatically see this massive amount of smoke appearing, right? Is the wood and the embers and all of that is just in contact with water, automatically vaporizes it. is a combination of high temperature and high pressure. The same thing is happening here. As soon as those rocks get in contact with the water, this is probably a water reservoir underground, or could be because the crust is melting, is releasing a lot of water in a divergent boundary. Right? Remember when I said in divergent boundaries, there's a lot of water that gets squeezed out. Maybe I did say it or did not say it, but anyway, there's a lot of water underground in volcanic activity areas. Okay, so this is a different type of energy transfer. This is, I'm going to call it a conduction. So I'm going to again go to my key. My made up key, and I'll put an arrow here. Bend arrow, we know that's energy transfer. Energy transfer, and I'm going to be even more specific and call it conduction. Perfect. Alright, so remember I gave a lot of people a hard time for showing an energy transfer by not showing where the energy transfer came from or where it went to. So if the energy is being transferred, it's got to be transferred from someone to something, right? So we need to show here, I'm going to put this as water. Here we go. Okay, so it's coming from, the energy is coming from the rocks to the water. And obviously, in order for this to happen, the water has to be a lower temperature. Okay. And actually, I'm going to do it slightly different. This is the beauty about models. Okay, you have to keep constantly changing your thought process, and I'm doing this as we speak. And the reason why I'm doing this is because, remember, water is a fluid, and as the water, the edges of the water heats up, it's going to begin to convect. Okay, so keep that in mind. So the edges of the water is going to be in contact with the rock. They're going to touch. It's going to be by the energy transfer is going to be by touch. However, in this reservoir is going to convect. Okay? If it is a very, very tiny stream, the convection will probably be very small. But in this case, in this picture, I'm just showing that there's some convection going on as well. Okay? Again, don't forget to keep going back to your key. I'll just put it here slow. Okay, slow. And then I'll put this is water. Okay, so right now I have all my key. Perfect. Alright, so I'm getting there. So, okay, so I have here how the water is getting heated up. And I'm not going to write in here just because we don't have time. We don't have space to show this. But what I would show is two things. I would need to show, because this is part of the unit, I would say here somewhere that the convection is happening because of density. Okay. And I can actually show, okay, show that as it rises, it has a very low density. Okay, I'll show this as low density, so low D or low density. And I'll show here that sinking because of high D. Okay, so low density, high density, that's what how the convection is happening, right? And I would say somewhere here due to temperature. Due to temperature. So it's hard to see due to temperature. Alright, so this model is looking cool. So right now the only thing that we have left is that smoke, which again is not We explained the phenomenon. I'm just kind of finishing it up by putting the, since that we're going to overachieve here, we're going to put some radiation coming out. Remember the heat, some of it is through radiation. So I'll get my little arrow over here, and I'll put that this is radiation. This is like a review of the unit, actually, which is good. Okay, this is your radiation. But then I'm going to create another one of this, and I'm going to call this water vapor. And in here, I would put the water vapor, what is forming vapor due to high temperature and pressure. And that's pretty much the end of it. Okay. So just a quick review. Let's begin from the core. You have the core of the Earth, which is the source of the heat here. Through the different layers of the Earth, there's convection happening of the magma, right? Where high density, did I get this correct? Let's see, high density, see, that's why it's important to go back here. High density sinks, low density rises. That's it. High density, right, showing here that's compact together. High density sinks, low density rises, and the reason why it changes in density is because of the temperature. Good. So then we move to the crust. The crust is not up on scale, it's just zoomed in. We know that this crust is in a divergent boundary. It has tons of volcanic activity, so there's hot magma and magma chambers everywhere. There's also a lot of water in the crust, and there's some water reservoirs or water pockets that form. The rocks they're in here are the partially melted rocks. When they touch the water, they transfer heat. Okay, that heat causes the water to expand and generate tons of pressure, and that's the reason why you see the vapors up here. I also put in big chambers, or in a bigger chamber, you would notice some convection of the water happening here. So that's pretty much it. All right. And again, I forgot to push this up. Okay, so let me push this up so you can see what I'm talking about. Okay, I forgot to put this up, so I'll say it again. So there's volcanic activity over here. There's partially melted rocks. When the rock touches water, it's going to transfer heat very fast, so through conduction. Okay, so it's going to transfer heat to the water. Okay, the water in a heat transfer is going to expand, right? Any object when it becomes hot, it expands, takes in more volume. The expansion is going to cause pressure to increase, and also is going to increase in temperature. So eventually it's going to be above 100 or 220 Fahrenheit, which is the boiling point of water, and eventually it's going to come up as vapor. Okay, I think that's the part that I did not show you guys. I wanted to emphasize that as I was doing this, I had a key, okay, to show all the things that I represented in here. Okay, I wanted to show you that. Alright, sorry about the forgetting to move up and down, but hopefully this was helpful.